Hello, Professor. My name is Ujjwal Pathak, and I decided to build a Pokemon classifier using convolution neural networks for the final term project of the course Deep Learning. So initially, I was researching a lot about like from where I can get the data because the data I was getting from various data sources was less, like 800 images or 1000 images and stuff like that. So finally, I found this particular data set, original 151 Pokemon images from the Kaggle data source, and it contains like 151 different Pokemon images with 236 or 240, around 240 samples of each Pokemon. So the data was of 9 GB, which I downloaded on my local machine. And so once I got the data, I started building the Pokemon classifier. So I loaded the required libraries at first, keras utils, and then OpenCV Python. And so here I attached code for image conversion, then resizing of the images to 128 by 128, then normalizing the images and plotting the normalized images. So as you can see, here's the convert to JPG code, then resizing image, then normalizing the image. And here I use NP-array and then plotting the particular image. So then I got the image data, images and labels for every Pokemon. So since the examples are like too many, like 250 examples per directory, I decided to take like 15 images per Pokemon to run on my local machine. And that's the iteration, and that's the images. So the images contains all of the Pokemon directories, but 15 samples of each Pokemon. So this is FFHD. And then I converted the images list into the image data. And the shape is like 2265 samples with 128 128 size and 3 channels. So next was factorizing the labels and okay, and these are the names. I stored each label names into the names list, and then I converted the or you can say ordered or assigned each an integer value from 0 to 150 to every label, every name, in the same order which the images are stored. So and then I splitted my data into training and validation sets, and then I started building a CNN model. So initially, I just built a one layer or two layers CNN networks, which was 32 shape and 64 shape, and then I kept adding layers to increase the accuracy of the model. So finally, this softmax classifier with 151 as as we have 151 classes. That's the model summary. And then I fetched the data, extrain, train, and validation data, and calculated the accuracy, that is loss, validation accuracy, and training accuracy. So after 20 epochs, I got the accuracy of 94%. And then I plotted the training and validation loss. And so for the testing purposes, I built a new data set and I downloaded like 26 images of particular Pokemons, like two Pokemons. You can see the test data here. And then I converted as the same way how we prepared the images, and then the predictions, labels, the score. So I got the score of